Okay, so when we last left off, we had a rocket that we could fly around the screen smoothly. I offered you an optional challenge to make a scrolling background, and I appreciate those of you that submitted that. And I did have some people submit the meteoroids that you could destroy with the missiles. So great job for those of you that are able to accomplish that. And we'll continue to use that going forward. But for now, I want you to be able to resort back to this if you can. What I'd like you to do is to in our classroom. There should be a Rocket Defend Part 2 assignment, and there's a vector.py. And if you click on it, it looks like this. And this has got some stuff in it, some code that I want you to download. And to download, you usually got to go to these three dots. And you got to tell it to open in a new window. Not really sure why, but you do. Then you can download. Okay? And I have my browser set to ask me what I want to do. And I always recommend people do that so you don't just automatically save it in your downloads. So when I say, I'm going to say save file, and I'll navigate to where I want it to go, which is the folder that has my Rocket Defend application. And there you can see I have it saved there. If yours just automatically downloads, then it most likely goes to a downloads place, and you'll have to go and find it. It's called Vector. And then when you find the file you want, say it was this one, you could say right click on it and say cut, then navigate to your folder and paste it where you want it to go. But we need to have it in the same folder that has your application. And while we got it up, let's talk just a little bit about what this is. This is called a class. A class is like a factory. It's a factory for making objects. We have used objects before. We've used a turtle object. We'd make a turtle named Hank and say Hank.forward, Hank.right. We've used objects such as the actor. So if you look at our code, you will see that we have been using an actor object. And you can tell because almost always classes start with a capital letter. And then when you say the name of a class, you then input in parentheses what describes the kind of actor you want. And that's what I have here. I have capital V vector. And it will make vector objects that we will learn how to use after you download. Okay, so now hopefully you have that set up in the right place. Well, what we're going to do is we're going to import that into this project. And what I'm interested in importing is the class vector. So I'm going to say from vector, import vector. If I just said import vector, then we would have to say vector.vector. And that's kind of annoying. So I'm going to say from vector, so from the module vector, import the class vector. I could have other classes. It turns out that's all I had in there. So we probably could have said from vector import star to be the same thing. All right, good. So now what I want to do is I want to do a little bit of changes to how our let's see here. I want to change a little bit of things about our keys. So first thing I want to do is I'm going to remove the down key. So I no longer want to have presses. Okay. For some reason I have fire in between my on key up, and I don't like that. That's confusing. Okay. So I have on key down. I'm removing the down arrow. If you want to come back and add it later, feel free. But for now, I want to go ahead and remove that. So I can now only move left, right, or up. And I'm going to change my update rocket method. Okay? We have an update command here. The update calls update rocket and update missiles. So in our update rocket, let's go to that. Okay, first thing I want to do is I want to make a new variable for speed. So I'm going to call it rocket speed 5 because I don't want to use these magic numbers. That's pretty bad coding, okay? We need to have variable names so that we know what the 5 is. If they press left, I no longer want to simply move the rocket left like it's strafing. I want to change the angle of the rocket. And I'm going to call that turn speed. So I'm going to make another variable, and I'm also going to stick with 5. I think 5 is just a good, nice, medium number. But now we can come back later. If it's turning too fast, we change this number. If it's moving too fast, we change this number. We can even put a comment. Controls rate of turn. This controls speed of motion. So I'm going to change my angle by turn speed. Notice that when I turn left, I'm going to change the angle. Oh, not minus equals. Actually, let's do plus equals. So turning left is going to change the angle by plus equal speed. So if you recall, the angle starts here, and it will move this way in a counterclockwise manner. So if I want to turn left, I need to add to the angle. If I want to turn right, I'm going to take away from the angle. If you ever forget this, just try one, and if it's not the right direction, go back and change it. So this time on turn right, I'll subtract the turn speed. Okay? Now, if they're pressing up, this is where the fun happens. So we're gonna make it a rocket vector object, and we say vector, and we give it two things: rocket.angle and rocket.speed, or rocket underscore speed. So now is the time to talk a little bit about what a vector is. Those of you that are in physics, probably this is bringing up maybe some memories of some bad quiz grade. But let's talk about what a vector is right quick. So a vector is a mathematical quantity that has magnitude and direction. It's usually represented by an arrow. So this arrow has a direction, right? It's the direction that it's going. We measure angles counterclockwise from horizontal, right? So it has an angle maybe 45 degrees, right? And it has a magnitude. The magnitude is how long it is. So we use vectors all the time. When I say, hey, I want you to walk towards the grocery store for about 30 steps, and then you should see a statue that I left there or something. You know, we're telling people to go a direction for a certain length. So, you know, another vector might be pointed in this direction, but not be as big, and it would have this angle here, like maybe 130 degrees. Maybe another vector down here. Okay? So what the vector object is going to do is it's going to take a vector that we have. Let's go back to this original one here. And it's going to break it down into what are called components. And it's going to say, okay, a vector is a set of instructions. We want our rocket to start here and finish here, right? And what it's going to do is it's going to take the angle that our rocket is facing, the magnitude that we're going to move, and convert it to a change in x called dx, and a change in y. So instead of me telling my rocket, I want you to move forward at a 45-degree angle, we're going to tell our rocket to move to the right a certain amount and then up a certain amount, which is good because that's the only way that it allows us to move it. Now, from our vantage point, we're going to see the rocket as if it moved on this arrow, because we'll see it in this image and then we'll see it over here. We don't see it slide right and then slide up. That's going to happen in the blink of an eye in between two frames of the monitor. And so that's all our vector class is going to do. We're going to give it a magnitude of an angle of a vector. That means the length. We're going to give it the angle of the vector, and it's going to tell us the dx and dy. D stands for change in. Delta means change, the Greek letter. So it's going to tell us the change in the x, change in the y. And it's that simple. So we've created our vector object. Now we just need to make it do what we want. I'm going to change my rocket x. I'm going to say plus equals rocket vector dot get dx. That's the name of the method that tells you the change in the x that would result from this vector. And then I'll say rocket.y plus equals rocket vector dot get dy. All right, just need to bring up some references here. All right, y'all, let's try it. So if all goes according to plan, we should have a very different experience. So you'll see now that our rocket does not move. Well, I would say it moves more like a rocket. And if you could add an image that when you press forward, the image changes to where it has fire coming out the back of it, that would be a lot cooler, right? I've seen that already. Now let's fire our missiles. And they are not working right at all, are they? That's because they're still programmed in that way that moves left and right. They're not programmed with a vector. I mean, I don't know. It's kind of satisfying, I guess. But let's go back and do that. Okay, so the problem with our missiles right now is that they are always going sideways. So we need to fix a couple of things about that. So the first thing we're going to do is we're going to go to our fire method, and we're going to add fire function, I should say. And M is a missile. So the way this works is we make a missile, we set its X and Y coordinates of that of the rocket. So that no matter where the rocket is, it will go to that location. But we're also going to take the rocket's angle now. So now whatever angle our rocket's at, we should have our missiles go at that angle as well. So there you see how they're now parallel to my rocket. Unfortunately, though, although I think that's kind of neat looking, the rockets are not moving, and that's because we're still moving them in that kind of basic way that we've done. We're not using a vector. We need to use a vector to describe the change in X and Y based on the angle and magnitude. So we're going to go up to our update rock missiles, okay? And we're basically just going to do the same thing. I have something called M speed already for missile speed. And my missile speed is 10. And we talked about how we have to use a while loop. We talked about how if you use a for loop, when you remove a missile, you can get an error. But what we're going to do now is we're going to move our missile. Right now we're just plus equaling to the x. So let's use our vector. So I'm going to call this mvect for missile vector. And we call the vector class, which will create a vector for us, and we're going to give it the. Well, you know what? I'm sorry. Let's get a reference to this missile first. So I'm just going to say m equals missiles bracket I. So now missiles, m is now a missile. Okay? M is now a missile. And we're probably going to change all of this, so we'll get rid of all that. So I'm going to say M is the ith missile in my list. So remember, when you want to get something from a list, you say the name of the list bracket I. Just to reiterate, so if I have a list called my list and it equals Q, R, S, T, U, V. If I want to get my list bracket 3, should be a T, because that's the third 0, 1, 2, 3. So that's all I'm doing is I'm getting a reference to it. So I'm saying like X equals my list bracket 3, so I don't have to say my list bracket 3 every time. I can just say X to reference it. So that's what I did. It's going to cut down some of my typing. So now M is the missile that I'm looking for. I'm going to create my vector by saying mvec equals vector, and I need to give it the angle of the missile, and then I'll give it my m speed, which we set up here in line 21 to be 10. Now I just simply need to change the x and y coordinates by the change in x and change in y that my vector gives me. So mx plus equals mvect dot get dx. Get dx tells you how much to change the x by. That's what the vector class does for us. Then m.y, mvect get dy. But now we have quite a bit of conditions. Earlier, we removed a missile, because if we get too many missiles on the screen, it can start to slow down our program. We removed a missile when its x value was so large that it was bigger than the width of the screen. But now we got to check up, left, right, and down. So I'm going to say if my missile.y is less than 0, or my missile.y is greater than the height, or my missile.x is less than 0, or my missile.x is greater than the width. Those are all the different ways you can run off the screen. You can run off the screen up at the top. That's where the y is less than 0. I can run off the screen down below. That's when the y is bigger than height. I can run off the screen to the left when I'm less than 0, or to the right when I'm greater than width. If any of that happens, missiles dot remove, or I can just say missiles dot pop I. I could say missiles.remove m, or missiles.pop I is probably the best way to do that. So pop means remove the missile at the index I. All right. And then I'm going to say else I plus equals 1. So I don't want to go up, because when I pop off a missile, they're all going to move forward in the list. So I don't want to do that if I just remove one. So I'll wait, and I'll say else. All right, let's run it and see what we get. So as you can see, we have a lot more freedom in what we can do. We can make some changes to our code very easily by changing the rate at which we turn. I can make my turn speed slower. And it's going to have kind of just a different mechanics to the game. You know, we should probably add that we can't fly off the screen. All right, so that is the applying of a vector. Okay, so what I want to do is I want to take a moment for us to try to understand the code in the update rocket function. I think we understand update missiles. I think we understand the missile speed, and I think we understand vector well enough that the vector tells us how the x changes and how the y changes. But I really want to go through this loop and how all this works. I'm also realizing I should have called my rocket a ship because I keep getting rocket and missile confused. But so let's talk about this method and this function. Let me go ahead and just grab a little bit of an image of it so we have it there to look at. And we're going to do what's called code tracing. Okay. Let me enlarge this a little bit here. All right, so we're going to go through this and say what's happening. All right, so when we come to the update rocket, at this moment we have a list of missiles. The list of missiles is likely not more than 5 or 6 long. When the game starts, the list of missiles is empty. So what I'm doing is I want to represent these missiles with letters A, B, C, D, E, F, G. Each one of these is a different missile. I just didn't feel like drawing a missile. So here's what we do. We start with I equaling 0. And that I is representing an index. So when I equals 0, the missile that I'm talking about is the one I'm calling A. We're using a while loop. It's been a while since we've used a while. And while loops are loops that continue for an unknown amount of time. They're going to continue until this statement is no longer a true statement. Okay? That's the whole purpose of the while loop. So if I knew exactly how long it would last, I would use a for loop. But because I don't, I need to use a while loop. So as long as I is less than the length of the missiles list. Well, the length of my missiles list is 1, 2, 3, 4, 5, 6, 7. So this is asking, is I, which is 0, less than, remember less than sign makes an L. Do you see the L shape here? Looks like an L kind of at an angle. Is that a true statement? Well, it is a true statement. So in this situation, if we have 7 missiles, we would then enter this block of code down here. And M gets assigned the missile at location I. So according to my little diagram here, M becomes A. I don't make a new missile or anything here. I'm just giving the missile in this location here a name that I can call it. I'm calling it M. So A is my M. I am now going to calculate the vector that I need to move that missile based on that missile's angle, that missile's speed, and I move that missile's X and Y accordingly. And that's, I don't want to worry too much about that. Hopefully you kind of got the idea there. What I want to talk about is this. So that particular missile, somewhere on the screen, that missile A is somewhere on the screen. It just moved somewhere else. Okay? If the new location of that missile, which was A, which we then renamed M, if that missile's Y coordinate is so that it is way up here off the screen, way down here below, that's right, remember the Y coordinates get bigger going down, or way to the left in negative land to the left of the screen, or to the right off of the screen, any one of these four situations, I need to remove it. So let's imagine that this missile that I called A, that is at index 0, let's imagine that it was too far now. It just moved off the screen. So what I do is I call missiles.pop_i. So pop_i goes to where when you say pop and you put a number here, remember I is 0 at this moment. So I'm saying pop at index 0. So it's going to go to index 0, which is here. It's going to take that and delete it. So then what happens? Well, all of these guys slide forward. B is the new index 0. C is the new index 2. C is the new index 1. D is the new index 2. E is the new index 3, etc. And now what about this end here? Well, that's gone. There's no more, that's no longer a thing. And so notice that this time I don't say I plus equals 1, because I either pop or I advance I. I don't do both. All right, let's go back. So we're done with this line of code in our while loop, so let's go back to this statement here. The while statement. Remember, this code here will keep running in a circle. I less than missiles. We didn't change I. So I is still 0. We're asking, is 0 less than, well, what happened to the length of the missiles? 1, 2, 3, 4, 5. Well, now it's 6. So we didn't advance I anymore, but this number got smaller. So if we kept removing the thing at the front, eventually there'd be nothing left, and we'd have 0 less than 0, which is false, so we'd exit. All right, so now this M, missiles becomes, M is missiles bracket I is still 0, so now M gets to be B. We moved this missile B, we renamed M. And let's imagine that it doesn't go off the screen, right? This missile B went maybe right here, and it's still on the screen. So we don't pop it, and we instead advance I. So missile B is safe for now. It's not being removed. Its life is spared. And we go over here. Now we got to check this while condition again, but this is no longer 0. It's the length of the list is still 6 because we did not remove anything to the list, but now I is 1. It is true, and let's imagine that we went through here, we moved missile C, which we renamed M, and this time it's off the screen, so we remove C. It's gone. Well, what happens? We're going to slide everything down. And I want you to notice how we don't advance the I, because if I advanced I to E, I would skip checking the missile D. And I don't want to do that. All right, we go back to the while loop, and now I is still a 1, but our list is now smaller. And this will continue going forward like this, and either the list will get smaller or the I will get bigger. And if we don't make any more changes, then I would just slowly go all the way past. And when I finally reaches 5, it's going to say, okay, the I is no longer less than the length of the list. Remember, the length of the list is always 1 more than the last index. So I don't get to do this anymore, and I stop that code. And that's what's happening in the update missiles code.